Hello, my name is Klaus Runebeck, and I'm a physicist and senior expert for the lightweight deflectometer, or for short LWD, calibrations at ZORN instruments. In this video, we will show you how an LWD calibration works. The ZORN lightweight deflectometer is a field testing device for evaluating the compaction quality of soils, predominantly in road and railway construction. The measuring principle is very simple. The operator lifts a weight along the guide rod to a defined height and lets it drop onto a load plate. The falling weight impact presses the plate against the ground. An acceleration sensor is attached to the load plate and detects the vertical plate movement. The sensor signal is used to calculate the so-called deflections of the plate. That is how deep the plate is pressed into the ground by the falling weight impact. Well-compacted soils show very small deflections. Here on the display, for example, you see a magnitude of 0.6 millimeters, which corresponds with a dynamic deformation module EVD of 37 MPa. This would be a usual result for average to well-compacted sand. When using an LWD, always check whether your device has been calibrated correctly. This is very simple and done quickly. There are labels and stickers on the device which indicate details of the calibration. In addition, you receive a calibration record which comes with every calibration. Furthermore, you can check related information stored in the electronics box at any time. This is the ZORN Instruments LWD calibration stand. The stand basically consists of these 5 components: a solid steel pedestal, a foldable bridge for 3 displacement transducers, a holding device for the guide rod. In the background, you see a computer with 2 screens and a measuring amplifier. Now, what happens exactly during a calibration? The loading device. We look at 2 variables: impact, that is the maximum force with which the drop weight hits the load plates, and impulse duration. For this purpose, the so-called loading device, which consists of the drop weight, a guide rod, and a set of steel springs, is first placed on the force measuring device. Then 3 series of measurements are completed with 10 impacts each. Impact force and duration are automatically transmitted to a computer. The measured values are documented in a special program. This program also calculates whether the values comply with the calibration standard. If necessary, adjustments to the LWD settings can be made directly on the stand. So, for example, the drop height can be changed to correct the force, or the so-called preloading of the disc springs that help synchronizing the impact can be changed to adjust the impact duration. For a 10 kilogram drop weight, the force must be exactly 7.07 kilonewtons. This means the device generates a so-called maximum ground pressure of 0.1 megapascal, or meganewton per square meter. This ground pressure corresponds approximately to the load with which the lorry presses on the road, and that is when it is fully loaded. i.e. with a 10-ton axle load and travelling at 80 km per hour. The impact time is 17 milliseconds and may vary between a maximum of 0.5 milliseconds during the individual impacts. In a second step, the plate deflection is calibrated. To do this, the load plate is clamped onto the steel platform. A special flexible mat is placed under the steel table to allow a defined deflection. Then this displacement transducer bridge is folded down onto the load plate. The load plate is connected to the LWD electronics box and work can begin. During the calibration, the deflection values calculated from the signal of the acceleration sensor are now compared with the mean value of the settlements of the 3 inductive displacement transducers. These measure the movement of the plate directly. The operator does this for 3 different measuring ranges, which corresponds to values as they are measured on soils with different degrees of compaction. To be precise, these so-called target values are 1.4, 0.5 and 0.3 millimeters. 10 measuring impacts are carried out for each settlement range. Data is transferred to the computer again and automatically evaluated by the calibration software. If there is a difference between the calculated and the measured deflection values, a correction factor is stored in the LWD electronics box. Calibration is now complete. If all values have been met and necessary adjustments have been made, this device will get a fresh inspection stamp and is ready for use again. In Germany, every lightweight deflectometer needs to be calibrated annually. That's mandatory. Rules might be different in your country. Please ask your local ZORN partner or contact one of our international calibration centres. Of course, you can call your local ZORN partner or ZORN Instruments in Germany if you have any questions. We'll be happy to assist you.